Ladies and gentlemen, welcome to the roundtable discussion on lightweight versus heavyweight sustainable construction. I am Lukáš Ferkl, Director of UCEEP, and it is my pleasure to introduce today's workshop, which is supported by the Ministry of Education, Youth and Health of the Czech Republic within the Inter-Excellence program. Big thanks also go to my backstage colleague Karolina Tomešová, who prepared everything for today, and also thanks to the Czech Green Building Council for the help with today's workshop. We are looking forward to the following 90 minutes where we will focus on the central question, which is, does it make sense to combine lightweight and heavyweight construction from the environmental point of view? The discussion is a follow-up event of a Horizon 2020 project called Hybrid Geotabs, and the first public event of our project association called EnerCore. And first, our roundtable panelists will give short introduction on the discussion. Then we will listen to the discussion of the roundtable, followed by key takeaways for the practice. In the final half hour, there will be room for questions and answers from the public, from you. You can see the Q&A section in your Zoom window now in the bottom line. So please type in your questions as you like. We will answer them in the final part of our program. The important thing is put the questions in the Q&A, not in the chat window. So use the Q&A's window. So who will be our crew today? Let me first introduce our four panelists. It's Stefan Winter, Chair of Timber Structures and Building Construction at Technical University of Munich. Ilari Aho, Vice President for New Business Development and CSR at Uponor. Wolfgang Streicher, Vice Rector for Infrastructure at Universität Innsbruck. And Bjarne Olesen, Professor of Indoor Environment at DTU. The moderators of the roundtable will be Lieve Helsen, Professor of Applied Mechanics and Energy Conversion at KU Leuven, and Wim Boydens, CSTO at Boydens Engineering and Chairman of our EnerCore consortium. The takeaways will be delivered by Anne Kaminad, Engineer and Project Manager at Lemon Consult, and Zuzana Procházková, Head of R&D at PIF Architects in Spain. So enjoy today's program. Do not hesitate to write your questions in the Q&A section here in Zoom. And let us start by the introductory remark of Stefan Winter. So Stefan, the floor is yours.
Thank you very much, Lukas. I just have to manage to show you my screen, and I hope this is working now. Hello to everybody. Screen is okay, Lukas? Okay, thank you, Wolfgang. Very short introduction. Light or heavy was the question you asked, and I want to mention very few points about the role and definition of timber structures. At the beginning, these are definitely traditional timber structures. Are they lightweight or heavyweight? On the left-hand side, original draft rafter from 1560 with a lot of clay in it, for example, not really a lightweight structure. And on the right-hand side, massive timber construction from Switzerland from 1760, also not really a lightweight structure. Well, during Bauhaus area, and we have this building from Neufert or the summer cottage from Albert Einstein. These were really lightweight structures, timber framing, with very thin insulation. Insulation is approximately, compared to our insulation materials, 4 to 6 centimeters maximum. And in those buildings, of course, the summer heat insulation was not the best ones. The barracks are the other buildings from the military, which have a very bad image according to especially summer and winter time, of course, heat insulation. But that's a reality nowadays. This is a building, these are pictures from a 70-story building, timber building in the heart of Berlin from Kaden Klingbeil. And what you can see, it is hybrid. It has a timber concrete composite floor. It has a number of concrete parts in it, of course. And we call timber buildings which have in total a volume of the construction products, which is about 50%. The next example, very shortly, some examples. A building from Hermann Kaufmann in Vorarlberg, Illwerke, an office building, timber concrete composite floors, timber structure in the outdoor areas. Is it light white? So what we are talking about. Brumunddal, Norway, north of Oslo, 18 stories timber structure, heavy timber structure. And if you have a close look to that, also concrete floors partly on the top, but that's more on dynamic situation or dynamic design, very massive timber structure elements. Is this really a light white structure? Don't worry about the architecture. That's another point at this picture. Light white structures, of course, we are using for top on roof structures for densification in inner cities. It's an example from Munich, Arzerstraße 32 by HKS Architects. This is in the main parts a timber framing structure, and it's the only way to build 2 stories on a 70 years masonry building. Otherwise, it would be too heavy, of course. But if you have a look inside, massive timber floors, screed, of course, available. Is it a light white structure? And this is a picture of one of our developing areas here in Munich, where all the buildings you can see here are timber buildings. So with a volume of more than 50% is built in timber structures. The outdoor, the exterior walls are timber framing with high insulation, of course. The inner parts are partly concrete, they are partly massive timber. But the main point is that the balloon around the building, that the roof structure and that the exterior wall structures, of course, are very highly insulated. And they are light white, but they are very well insulated. And my last slide, if you look on a can like that, you know, everybody, what we have to ensure in our buildings is to delete convection, to reduce heat flow, to reduce radiation. But what you also know, if you look at this picture, it's keeping warm if you put hot tea in it, but it's keeping cold if you put iced tea in it. And so what we need is, of course, always a combination. And my view to the future is that we need very lightweight constructions around the balloon of a building, so to ensure very high insulation quality. On the other hand side, there is no real lightweight building nowadays available. Hybrid is reality, and the urgent need to realize resource efficiency. And that's why we have to think with all construction products to minimize the use of material and therefore the use of primary energy and resources for our buildings. So the big question is, where is really a borderline between lightweight concrete, for example, if you're looking at the research of Mike Schleich in Berlin, or other lightweight structures. Thank you very much for your attention.
Thank you, Stefan, for this this kickoff with a lot of questions, but turning around the same focused question. I think this inspires us for the rest of the roundtable. And now I would say, give the word to Ilari to talk us about heavyweight structures. What's the future? Where's the floor, Ilari?
Thank you, Wim, and thanks to Stefan already for the opening remarks from the lightweight side or the hybrid side. Stefan took up a couple of very important points, which I'm now going to improvise a little bit on in the beginning. I think it's of fundamental importance not to mix the discussion of heavy versus light versus hybrid with the discussion of different construction materials. And especially here in the North, we have a long-lasting yes-no argumentation ongoing between different construction materials and their environmental benefits or drawbacks. That, to me, is a discussion that goes beside the point. I mean, the point should be what types of design solutions, whether those are structural or otherwise, what types of design solutions improve the functional performance of the buildings that we construct. And that, to me, is a discussion which is a little bit independent of what material platform you use. With regards to heavyweight construction, and thanks again to Stefan for taking us a little bit in the history of lightweight construction, I would go even a little bit longer to make the claim that, as you all are aware, some of the very, very first human settlements were sort of extreme in the sense of heavyweight construction. And now I'm talking about caves. The reason why people moved into caves early on was exactly the benefit of having thermal mass around you to protect you from the fluctuations of the external environment. And maybe even once we invented fire at some point, maybe even store some of that heat within the cave. So humans have for a very long time understood the inherent benefits of thermal mass. Again, this is not necessarily about individual construction materials, or it's not necessarily even about structurally heavy construction. Well, I'll come back to that in a moment. Now, if we fast forward a couple of 100,000 years from the caves to the modern day, in my books, there are three big drivers for the construction business, which have their impact currently and in the future on heavyweight construction, structurally heavyweight construction, but on construction otherwise as well. And these would be, from a construction business point of view, productivity, quality, and output improvement is probably the biggest business driver at the moment. We all know that construction is lagging behind in productivity compared to many other industrial sectors. The second thing, which goes a little bit hand in hand with productivity, is environmental footprint minimization. It goes hand in hand with productivity because the more productive your resource use is, the better is the environmental footprint, of course, of what you construct. We see a very strong movement towards net zero and even net positive buildings and neighborhoods and so forth. And there's no stopping this trend. If you look at what's happening with the, for example, the financial markets and the just released EU taxonomy, it puts a lot of emphasis also from the investor perspective on environmental performance of the building sector and technologies. And of course, then the third one would be digitalization. I'm not going to be touching that too much because it's an overarching thing. It has its big impacts on potential to improve productivity and potential to improve environmental footprint and so forth. But it's going across everything that we do in construction. So what do these drivers then mean for heavy construction, heavyweight construction? From a productivity standpoint, the obvious example, and Stefan actually had a slide on this topic from the lightweight side, and this is industrialization. Really the only way of dramatically increasing productivity in construction is to move more and more steps of work away from the construction site, either to factories or to what I would call on-site prefabrication. I will come back to that in a moment. Now, heavyweight construction, both in terms of, and now I'm falling into my own trap of talking about individual materials, but nevertheless, heavyweight construction has a half a century at least tradition of industrial prefabrication, both in terms of prefabricated steel frame elements and in particular prefabricated and modular concrete elements. So there is an industrial platform in heavy construction for industrialization and prefab. Now we also, the other side of that same coin is that we all know, if you look at the concrete element construction in European suburbs from the 60s or 70s, those leave a lot to be wished for in terms of durability, quality, both architectural and technical quality. They leave a lot to wish for in terms of energy and environmental performance. But as the tradition of industrial efficiency is there, it provides a much better platform for also building industrial prefabricated heavyweight solutions that have their, let's say, quality and environmental characteristics in the right shape for the future. For heavyweight construction, the big ticket item in environmental footprint minimization, of course, is the upstream embodied carbon and other embodied environmental impacts that construction companies and building owners inherit with the materials that they use. You are probably all aware of the very big industrial development projects towards low carbon or no carbon cement, concrete, steel. We have here in the northern parts of Europe, we have heard about published investment plans in the order of magnitude of billions of euros to no carbon steel manufacturing, also for construction components. This will definitely drive the environmental competitiveness of heavyweight structural solutions. Forward remains to be seen what happens with the cost competitiveness, but I'm rather sure that those levels of investment would not be initiated without the companies in question having a really optimistic view on also the cost competitiveness of these materials. And of course, I'm very far from being any kind of a material science expert, but if we look at the world around us, material sciences in many aspects, not only in construction, and I think construction is even a little bit lagging behind other developments, material science has made dramatic advances over the last years and decades. And I would assume this scientific development to come with completely new inventions in terms of construction material platforms. For heavyweight, another critical thing from an environmental footprint point of view, of course, is finding solutions for optimized transports and logistics in terms of these structurally very heavy elements. The higher the mass we transport, of course, the bigger the transportation emission impacts will be. And we also know that one of the most difficult things to decarbonize in our society is the goods transport sector, in particular road transports, and there heavy construction materials play a large role. This also brings me back to the potential notion of on-site prefabrication. I mean, 3D printing of concrete structures on-site, completely customized for the project in question, but still industrially prefabricated in a way digitally. That's one example of moving industrial construction to the site level without jeopardizing or compromising on the, excuse me, the productivity impacts. So there are inherent benefits of heavy structures, and we will be talking about them, I trust, in due course. These span from thermal comfort to peak load balancing and peak load reduction to integration of renewables. I'm sure Bjarne will be talking about low temperature heating, high temperature cooling, and the relation of that to thermally heavy structures. The way I see, and I think here we agree with Stefan, the way I see the future going is we will see new solutions, whether they are design solutions on the building level, structural solutions, or material solutions that will combine the benefits of, let's say, thermally heavy and structurally light. These types of hybrid solutions that Stefan was referring to on his last slide, I also do see coming, and that's where I also envisage the future of heavy construction to lie. So with that, I hand back to our facilitators.
Thank you very much, Ilari. I would gladly ask Wolfgang to step forward on the screen and, well, tell us something about the storage, energy storage, mass in the buildings. What can we do with it? And for me, for the moment, still mysterious terminology, the last layer, which I believe is something you want to talk about. You're still muted.
Yeah. Okay. So thank you very much. Do you see my screen? Is that okay? Okay, perfect. Thanks. Well, I will come to the whole thing more from a building physics side. Despite that I'm the vice rector, I'm a mechanical engineer, and I'm professor for energy efficient buildings and renewable energies at the University of Innsbruck. So let's have a look on the whole thing on the more, let's say, building physics side. So we have a lot of energy flows in the building, and let's say the flow we are talking about is these double arrows here. So that's what thermal mass should do. So thermal mass should, let's say, take up the heat when the room is warmer than the wall, and it should release the heat when the wall is warmer than the room. That means that we need variations in the room temperature that energy can flow in and out. So the room must be hotter than the wall to flow in and colder than it flows out. But the benefit is that if we take heat in here, that heat is not increasing temperature or reducing temperature of the air. So we reduce again the fluctuations. We need the fluctuations of the room temperature, but in the same way we reduce them. And if you have a look on it, forget about this formula up here. That is what is behind the driving forces. But this is a concrete wall of 33 centimeters thickness, and I varied the temperature on one side by 6 degrees, which is very much. So you have to find some customers, some tenants that allow a 6-degree shift over 24 hours. But what would it mean? That would be a very big shift here. And I put the temperature constant on the other side just to see what's happening inside here. And we see most of the temperature we lose in the heat transfer from the air to the wall. And then the heat will be evolving. If it's hotter in here, then there will be heat flux from the outer side or from the side where we have the fluctuations inside the concrete. But this flow only takes place if there is a gradient, because a heat flow needs a temperature difference. So they have a gradient inside. And the same thing happens when the whole thing is flowing outside. So we have a change, the wall is warmer than the outside, and then we get a gradient out here, and there's a temperature and energy is brought to the outside. So what can we learn here? We have in a 24-hour shift, and that is the main shift we're dealing with thermal mass. That means a day-night shift. We'll never take the heat from summer to winter with thermal mass, no chance. So we have a 24-hour shift to be taken into account, and we see in this massive concrete, which is a very good thermal mass, in the first 10 centimeters, there is quite some variation, but the rest, it's getting minor, so the energy stored here will become smaller and smaller. So it's more a question of, let's say, area of the thermal mass if you want to make use of it, and not the big thickness. And of course, if we have less thermal conductivity here, then there will be less heat transferred into the wall, and the whole thing will become much more steep. And let's say the deepness where we have useful temperature shift will become smaller. Okay, that's about what materials we need. And what is now useful? So why should we do it? And I come also back to lightweight in a second. So why should we do thermal mass? That is a very old simulation we did a long time ago with Transys. And we put this house here and we put different construction elements in there. So we started with a very lightweight construction. So a wooden sandwich with wooden beam ceiling and lightweight internal walls. And we came down here to a solid wall with 800 kilogram per cubic meter internal ceiling with clay, brick layer, and so on. And this is 2 summer days, very hot. And there have been 2-year simulation before that, so the house is already in its normal cycle. So we see the temperatures evolving inside. So the very lightweight construction, that was a barracks you were talking about. The barracks is getting very hot. So no heat can be taken by any wall because everything is lightweight and it doesn't take anything. But the more heavier it becomes, the more we can dampen the temperatures. And of course, it takes also more days that the temperature is evolving. And finally, we have down here, we have a pure concrete house. So in terms of overheating, thermal mass makes a lot of sense, but it must be accessible from the inside. So if we have here, would put an insulation or a wooden layer in here with a far lower thermal conductivity, then we won't make use of the thermal mass. Or if we have a suspended ceiling in an office building where we have about, I don't know, 30, 40 centimeters of air between the concrete and the room, then we have insulated the thermal mass away and it will not work. The same as if we make an elevated floor and things like that. So now we have a lot of construction materials. So if you take that brick, and the people say, well, let's build a concrete, let's build a solid building. Let's take a brick. It's not so much solid, the brick. It's a lot of holes in there because they want to make both out of it. They want to make an insulation and they want to make a solid out of that. The only solid thing here is the very first layer of that brick. So it has the same thermal mass as a cardboard layer or something like that. So it's very little. And even the even better ones, they're even less thermal mass in there. Why should in 24 hours should it heat up here in the back? There is no chance doing that. So the bricks are not thermal mass, and they're also not so good insulation material. I come back to that. The other one is the wooden construction, the lightweight one. So this is a prefabricated house as we build it here. This will be American way of style building houses. Very lightweight, and the only thing here is the layer inside the gypsum layer, the gypsum board layer. This is about 12 millimeters thermal mass, and then that's it. So it's very good insulated, but it's no thermal mass in there. And on the other hand, if you build the concrete buildings, there's a lot of thermal mass if we don't insulate it away, but the insulation must be put separately on it. So what I finally, you see, it's a very, very old slide, nothing new here. So I am very much in favor of double layers. So we have inside for the statics and for the thermal mass, we have a layer here, and it could be 10 centimeters or even less. And on the outside, we have the insulation to keep the energy losses low and also don't get the heat in summer and so on. So this is the mixture, the hybrid one. So put thermal mass inside and insulation outside. And there is no material that is both. So because the thermal mass needs high thermal conductivity, a lot of heat coming in, a high density, we need that. If there is air gaps in there, they have a low thermal conductivity. So the thermal conductivity will be low. And we have to store as much heat as possible per volume. So that's specific heat. And on the other side, the insulation materials would have a low thermal conductivity and a low density, because we get a low thermal conductivity with low density. We need a lot of air with a very little surrounding around, then it's a good insulation. So there is nothing doing both, or we do both in a bad way. So again, a very old picture from Recknagel Sprenger. I put it to English, and you see bricks here, and the bricks, the new bricks I made down here, and the wood, they're quite the same in terms of density and thermal conductivity, and they're neither thermal mass nor insulation. And we have here the insulation materials and here the heavy materials, that is thermal mass. So we have to put them somehow together. And if you make a wooden building, a prefabricated building, you should add some thermal mass in there to keep the temperature variations low. And this could be a concrete ceiling or a floor heating system with some concrete in there that would add thermal mass. You can put also an ecological way and put some clay elements on the side or whatever you would put in there. And we saw some nice examples with this hybrid stuff. And in terms of cost, you can also reduce cost by using, let's say, a static ceiling and putting in additional functions like active weighted concrete ceilings or whatever. So where you make double use of things. It's the same thing here. If you have this in a prefabricated house, you put a a screed here and with the floor heating system, you have several things. You have a thermal mass in there, and you have also very much better acoustics in there, because you don't hear everyone walking up here and to the next floor. So it comes to the conclusions from this, let's say, building physics excursion on thermal mass and light weight. So thermal mass is important for indoor climate in summer. It's not here. We can use it also actively in winter. So if we have, for example, a PV on the roof and we have a heat pump running with a PV, then we can heat up the floor during the day and then make a use of it during the night, or the ceiling if we use ceiling heating. The same we can do in summer with cooling. We can use it for during the day when the sun is shining, and during the night it still is active. Then, and for thermal mass, it's not so much the thickness, because we're talking about 24-hour shifts. It's about the area. It's more about the area. And of course, there is no material being both. So thanks a lot. And I think maybe there is something to discuss about that.
Okay, thank you, Wolfgang, very much. We have 5 seconds of cooling down, and then we use the inertia of experience of Bjarne to bring forward some insights in radiant heating, radiant cooling, and advantages on the energy system or clean energy used for comfort in our buildings. Bjarne?
Yes, thank you. And I don't have any presentation, but maybe we should close the other screen.
Well, I'm just looking how I can close it. Stoppen. Yes, now I did it. Sorry.
You can stop.
Yeah. So, sorry, I found it finally. I should know already now after 1.5 years.
So, of course, when you talk about heavy and light, what we have talked about now has been very much related to the building itself. But a question is also heavy light regarding the systems you are using for conditioning of the building, where we can say light system is a full 100% air system. There's not much thermal mass in the air. And a heavier system is where we integrate pipes for heating and cooling in the concrete structure in itself. And there are advantages and disadvantages. So where mass can be important is, of course, to even out changes. It can be general changes due to the inside environment. It can also be due to the outside environment. So thermal mass is probably more relevant where you have big general differences. If you have buildings which are running at the same indoor temperatures 24/7 in the tropical area, thermal mass, I don't think plays such a big role. When we now talk about the system, so one thing is we would like to have systems that are what we call sustainable, can use alternative energy sources. And here it's not often a question about the mass, but it's more a question about getting the temperature you are using for heating and cooling close to the temperature you want in the space. If you do that, you have a much better chance of using alternative energy sources. Could be from solar panels, ground source heat pump. And in fact, if you connect your system to the ground, you have a heavy system because you are using the ground as a heavy part of your system. Water-based radiant heating and cooling system has become very attractive, both in residential but also in commercial areas. I think one of the main reasons is that you don't see the system. You can use the space fully. There's less maintenance. And then because of the large surface, they don't need so high temperature of your for the heating and cooling of your of the water you are using. That is probably the biggest benefit with this system. You can have radiant system which are you will call light, for example, suspended ceiling panels, which has often been used for cooling for many years. You can have capillary pipes integrated in the upper layer of the, or just at the ceiling, or you can have very heavy system where you integrate in the construction slabs. And then of course you have the discussion, yes, but how can you control it? Don't you need a light system to control it? And there's a big discussion about how well you can control, for example, tap system or more heavy radiant systems. And people have tried to use, to characterize the systems and their controllability by using, for example, the time constant or response time of system. The response time is of course important if you want to change from one condition to the other. If you have a space where you 1 hour want 22 degrees and the next hour you want 24, 26, then if you have a lot of mass in your, let's say, heating system, it will take some time because you have to heat up the mass. But often there's very seldom we have this kind of building. It's more a question about taking care of the fluctuations of the internal loads or the external. And here is mainly sunshine because the outside temperature change will be compensated by our walls normally. So it's more a question to compensate for changes in internal loads and their internal temperatures. And here, if you now have a system where the temperature of your surface and the water behind is very close to room temperature, you have a such high level of what we call self-control, that a small change in room temperature will automatically change the output, heat output, or the cooling possibilities. And because of that, even if you have a lot of thermal mass, it don't need to be a slow system for the control. And that's very important to look at that when you think about how fast you have to control and so on. So I think when we talk about the radiant system, people often think about heavy system and they are not easy to control. I think that is false. We should think about them that they can really bring the use of renewable energy sources in an efficient way into our spaces. And then we have to remember, in all buildings, we also need ventilation. And often the ventilation can be used if you want to have like a fine control of 1 or 2 degrees. So these systems will go together very well. Thank you.
Thanks a lot, Bjarne. We heard now 4 experts making their statements on lightweight, heavyweight, advantages, disadvantages, mainly opportunities. Now it's time to start the roundtable discussion, and maybe I would like to start by picking in on what Bjarne just said. You mentioned the part on the self-control of taps, of heavy systems in general. Not easy to control is often a comment we hear, and also concrete core activation is often perceived as a very slow reacting system. You already said this has to do with the fact that they often relate to what is produced and what is needed, that there is a time gap between both. But if we just want to compensate for disturbances, then it's actually quite fast reacting. Now, can you maybe very clearly state if people say taps, it's not easy to control. What's your guideline? How should we go? How should we control these heavyweight emission systems?
Well, you shouldn't control at all. Almost. I think what you should look at those systems is it's like a flywheel. You have in the building that makes sure the building don't go out to any tangent, get very hot and very cold. And if you try to control too much, that means you are using a wider temperature range for your control, it gets very difficult. So the important is that you try to design the system. And here, the important thing is the building design. If you have a building where you will have a lot of direct sunshine into the building, and because of the sunshine, you can change the load very drastically. And in the other part of the building, to the north side, you won't have much sunshine. There you have to take into account when you put out your tap system, because you're made to run them a little different temperatures in those two sides. So it should be rooms where you have more or less the same load, can run more or less with only a small variation in water temperature for your tap system. You will have a variations over the year. Some of the studies we have done shows, but small variations. And I also know some tap systems, they're basically running with the same temperature the whole year, like 22 degrees on the water side. But you need then, because you need to be able to adjust maybe individual offices, individual differences in people's perception, a couple of degrees, and that would be something you could do over your ventilation system.
May I also add something?
Absolutely.
Is it allowed? Okay. I will give my small residential building as an example. It is a prefab building, but it has a concrete floor. It's quite well insulated. And if you have a large area heating system and you have a well insulated house, you need a very little temperature difference from the surface to the room to heat the room. So it's in a passive house, it will be down to 1 degree or even less. So for the control, or if you have house half of passive house, maybe 2 degrees or whatever. So very low temperature difference. So if you run with a constant temperature, or you choose a room in the northern side where you measure the indoor temperature. The outdoor temperature is not important anymore for well insulated houses, because it's not really affecting. It's more the solar gains, the internal gains, whatever that are affecting. It's not outdoor. So you simply measure in one room the indoor temperature and take this as a reference room. And if now a southern room gets the sun, then the room is heating up. Yes, but now the temperature difference from the floor to the room is getting shorter, smaller, because it's only 2 degrees. So we call it, and then of course the heat delivered from the floor will get lower and lower. And if the room is getting to 24, despite the fact that the floor is heated, it will take heat from the room. So we call it a self-controlled heating system, which is very, very simple. So you take one reference room. With all the rooms that are similar, you can attach it. If you want to have one room higher or lower, you simply reduce the volume flow in that room generally, and then it will take less. So this is very, very simple control. And in that way, also the heavy building or the heavy heating system is reacting instantaneously without any time delay on lesser demand, because of the temperature difference, because now it's not the temperature of the floor that is being brought up and down. This will take a lot of time, but it's the temperature of the room of the other side that is shifting, and this is reacting without any time delay with the heat delivered to the room. And we build that quite often, and I want to try it always also for office buildings, where you can do it as long as you have similar offices all around. Have very, very simple systems without any control and valves and shifting things and whatever.
If I may also add to that.
Yes, please.
I think.
Ilari, I just wanted to know from Wolfgang, whether he has any data on the user perception of this way of controlling.
Well, I can say I raised 4 daughters with that, and they were not unsatisfied. But well, I have to look it up. But I think it can very easily. I don't have the room temperatures. I know them. They're not really varying if you have thermal mass in there. That's what Bjarne already told us. I mean, they're very stable, and you just have to keep them stable. And again, so you can have very, very simple control if you have the thermal mass and well-insulated buildings.
Yeah,
that's the both things that have to be coupled.
Yeah, okay, I agree.
The only thing I wanted to add to that was, well, I fully agree with what Bjarne and Wolfgang had just said. The only thing I wanted to add was that because of the nature of how these systems work, the only limitation in my mind really is that you don't want to put these types of systems in very special purpose buildings where you would need to actively change the indoor conditions at a very short time frame. But if you, as Bjarne said, if you are running a standard purpose building where the targeted thermal environment is known and more or less constant or close to constant over the year, this notion of tabs and other radiant systems being slow is just not accurate because of exactly the technical reasons that Wolfgang and Bjarne mentioned.
Okay, thanks a lot.
I just want to add also, many people, they could claim now floor heating is very popular, but then in the spring and fall seasons, they make it overheating in low energy buildings. And they claim that the floor heating is much too slow. But the problem is that they have conditions where they don't need any heating at all. So no matter what system they had, it would be overheating, but they think it's the floor. And to get that into people's mind, it's not so easy.
Maybe a last thing, because let's say in former times when the buildings were not that good insulated, we always were thinking a night setback will save a lot of energy. If you have a thermal mass, then forget about night setback. But if you have a well-insulated building, forget about night setback anyway, because you won't lose temperature during the night, or very little if you even have a temperature setback. So the effect of that is probably negligible in the moment with the very good insulated buildings anyway. So of course you cannot do that in a heavy building.
Of course, that means that the perception of the building user, which has grown in the past 30 years of energy efficiency, is of course different. If he comes in winter in his office at 6 o'clock because he has a lot of work, then he will probably not be used to having temperatures that are almost similar to daytime temperatures. So that's just a small remark. So we have to rework on that somehow and make the users understand, the users who are not in building physics or not in technical equipment to supply comfort to buildings.
May I add something?
Yes, of course.
I don't know whether you are able to see that. I agree fully with Wolfgang and Bjarne. What we should not forget at this point is we need, of course, an effective exterior shadowing, especially on the south sides and on southwest sides. That's absolutely necessary. And if we take everything together, you said, and we have exactly the same experience also with research on different type of boxes with different materials, with heavy masonry, light white masonry, mesh timber, light white timber. So everything you said, Wolfgang, it's exactly correct. The main important layer are the inner layers. And that's why, coming back to our original question, hybrid structures with a very well insulated exterior balloon around the building and the possibility to have mass-based radiation heating systems inside are also, in my opinion, and according to our built experience in the last 10 years, the best solution at all. And Ilari added a very good information. If you need, in some cases, a fast differentiate or a fast change of temperature or indoor conditions, you have to use, in addition, for example, ventilation systems. But these are, in my opinion, they only need, if you go to the research of Thomas Auer, for example, or Gerhard Hausladen in the past, you need also quite a low permanent ventilation. In Finland, it's quite high. It's 0.6, something like that. We found out that it's about 0.2 is sufficient for the comfort. Bjarne, we can discuss about that. I think it's 0.2, 0.25 is for the normal comfort is sufficient. And that's what our data are telling us. But that's another point to discuss. But finally, if we combine, and so we are back to hybrids, if we combine lightweight, very well insulating structures with the necessary thermal mass inside, then we have the right solution. And this is then very easy to combine with self-regulating heating and cooling systems. Gerhard Hausladen, Thomas Auer, they also researched about that. There are data available and it works. So I agree with Wolfgang that this is a very good solution at all.
Yeah. I want to add a bit, on, at least also on the questions here we have in our chat. Yes, sunshine. I not fully agree with Stefan. The most important is the east and west side to be shaded by the windows, because in summer on the south side we have such a steep insulation that the cosinus phi is 60 degrees. So we have a cosinus phi is half already. So we get only half of. It's more, let's say, spring and autumn where the southern side becomes important. But nevertheless, shading would be good. But there is a shading system that is not on the market, which would be very crucial to have, because we have an office building in our university. It's a 9-story building. It was completely renovated, more or less down to passive house. We have measured about, what was it, 12 or 13 kilowatt hours per square meter in year gross area. It's not a complete passive house, but nevertheless. But we have no cooling in the whole building. So what are we doing? There's a lot of computers and everything in there, people working normally. So we have automatically opening windows at night, which is working very well in Innsbruck because we have high mountains around and the nights are cooling. So that's fine. It's maybe not so good working in Munich. But that would be good to have a shading system that could be go down in the night and prevent rain in the thunderstorm coming in, prevent the burglars coming in, and still have enough openings so you can simply open the window without electronics. Just when you leave the office, you open the window. When you come the next morning, you close it again without any sensors, but you don't have to come in there when the thunderstorm is coming during the night and rescuing your computers for getting flooded. So here we have a complete lack in the market. We have a lot of shading systems, but they are all not storm resistant. So we need electronics and sensors and actuators to get them up and down, and hopefully it works. But if there would be something like these old shutters you just put around, they're safe for everything. But you cannot make window light direction stuff and things like that. So I think there is something, I discuss it a lot with the shading industry. So I think we have a lack here on good stuff. And normally if you have a shading system and you have all your building worked with that, then in the end, when the building is built and they run out of money, they just take out the shading system and nobody tells them what it's been. So yes, shading would be very important, but I think it is completely underestimated the possibilities you can do here.
Okay, so Wolfgang, you mean like with the shading, we can add more functionalities than we do nowadays. What I also heard that the controllability of the shading is an important issue to control the indoor environment a little together with the fresh air that we bring in. There we have a fine-tuned control option. And if the thermal mass would be activated, it is not such a difficult challenge for the control systems. However, we do have turnover from heating to cooling and such elements that will not be visible that much on the comfort side, but on the energy need side. So where we provide the heat and the cold. Of course, in the mountains, we have the cold from outside for free, I would say. Wolfgang, you don't agree with me?
No, I agree with you, but I just want to put in another point. So we have to find heat and cold distributions that are the same. So I'm very much in favor in the last years with the well-insulated buildings and having ceiling heating and cooling systems. So from the ceiling, with an activated ceiling, you can go down with 40 watts per square meter without being out of your normal your comfort. And 40 watts is 4 times passive house. So you can build quite bad houses having ceiling heating, and you can use the same system somehow to do the cooling. So just to prevent costs. So we have to look for the same system doing both. That saves us a lot. And it's simply to control. It's the same way of controlling in summer than in winter.
Okay, that seems reasonable. That's something that adds to the economic side for the investor, of course. If I would say conclusion, we can go further on it after that. We have the takeaways from some practitioners that are listening and try to give a reaction of their side. But still, I'm a little bit puzzled. Okay, we have advantages if we have a mass that we activate. It is easier to control that some fear. We have the connection with wooden structures, with insulation, that would be very good to do. We have an environmental impact. Is it correct? So it's maybe just a statement. We can come back after the takeaways from the practitioners. So then we get back into the Q&A session where we will ask some things to you. So you can see it as me as a practitioner asking myself, so is it an option, or is it a good option or best option to leave the concrete slabs? They have advantages on other sides. We should look at the environmental impact of the whole chain to produce them, to get into production, and mainly focus on the envelope to see where we can use more ecologically acceptable materials. So we would have a good result on both sides. Would that be a hybrid? I asked my last question before the takeaways to Wolfgang, and I take away a little bit a question that goes towards technical buildings and districts. So if you would be, imagine you're an operator or anyone in the panel, you would be an operator for a district electricity provision or a thermal network, and you have to provide everybody with comfort. Would you be happy, would you embrace to have a uniform landscape of lightweight buildings, heavily insulated, heavy buildings, or would you rather have a good combination of those two? What would be your preference? And question is mainly to Wolfgang, but anyone can interfere with that.
Okay. Well, I would like to have, if I purely look on it on the way of the district heating operator, I want to have heavy buildings that are not insulated, because then I can sell heat in a constant way all the time. As better the buildings are insulated, as more expensive the whole thing gets. But of course, we need insulated buildings. So I was just joking. But then I would need heavy buildings that are insulated, because it smoothes my heat demand over the night. So I can smooth my variation of the heat to be delivered. Because if I have only lightweight buildings and I have a winter day, sun is shining, during the day I can sell nothing, and during the night I have to give the full power because there is no storage of heat. So, and this is something I want to have full load hours with all my stuff. So, and a more smooth distribution. So I think, my opinion, but Stefan, he is not agreeing. So
I'm agreeing, of course, but the question is, what is a lightweight building? And I've shown the slides at the beginning. You can see you can ask what is a light white building. We don't talk about barracks construction or pure timber frame construction. We have, especially in the multi-story buildings, we always have concrete cores. We have timber concrete composite floors, for example. We have screed on the floors. Of course, if you're covering with a very high carpet, then that's insulated again, but that's a question of architecture again. And please don't forget, especially if you have a high number of massive timber, we have a C value of 2, not of 1. Even we have only a characteristic density of 500 to 600 kilogram per cubic meter. We also have a heat storage capacity. It's not so hard.
Your heat transfer coefficient is lower. That's why you can use even less density.
That's right, but it should not only have a look at the heat conductivity, you also have to take into account the uptake of moisture and the delivery of moisture, for example, and there are additional effects. But taking everything, and you have, of course, what you have, furniture, all the other things inside. You have a lot of mass inside available. So a building which has a light white envelope, very highly insulated, is not by itself a light white building. And what we should use in future is the aspect Hilary mentioned at the beginning. That's the third aspect you mentioned, that's digitalization. We are able to build a digital twin nowadays, and we should use the digital twin also for planning, heating and cooling, much more than we do today.
Okay.
And if I may add to that, we should also use the
simulation, and we very exactly know where we need the mass, how we can activate the mass, and where we need the light white high insulated envelope. And this is to be used in future. And this is not completely implemented nowadays, for example, in BIM, etc. We are not perfect in this area. We have to develop this area very much, and then we can do it at the point where we really need it. And then it's a question at the final end of hybrid structures and not of light white heavyweight. That's not the question. At the
looking for the ideal combination, Stefan.
One last sentence. At the final end, we have to improve energy and resource efficiency of our buildings. And we have to use for this exactly the 3 points Hilary mentioned at the beginning: industrialization, digitalization, and prefabrication.
Okay, I'm very happy.
My simple answer, Wim, to your question.
Yeah, but Hilary, you can. I see we have not that much questions in the chat yet. So you're welcome.
So Stefan's point on the digital twin was really fundamentally important. I would just add to that if I was the district heating operator or the power company operating an area, what I would want, as Wolfgang said, is as little difference between peak load and base load and as much operating hours for my system as possible. And I would want to have the digital twin for the area, not just for the buildings, so that I could optimize delivery between the buildings to shave even the rest of the peak loads away. And again, it's maybe much less about whether the individual buildings need to be heavy or light or hybrid. It's about how you manage, how you design and manage the system as a whole.
Okay, thank you. Maybe it's a good moment to switch to our two observers, and Suzanne, to hear or
yeah,
Susanna.
Thank you, Wim. Yeah, a lot of very interesting topics. It went a little bit outside what I thought first we were going to talk about, the really interesting things. Yeah, and I think from the beginning, I see as human people, we're constantly evolving, and we've really experimenting with thermal mass, and we moved on from the cave and the mud clay house, and then moved to lightweight structure, then back to. And I think everybody's trying to see that there is advantage in both of the type of construction, and as human beings, it looks like we're going towards hybridity, and it's good. It's also probably good news that we managed to combine, and we move away from this misconception of heavy weight structure or lightweight structure, and we try to combine the strength of both of them. And I think, yeah, we know the problem these days is that since we are getting more and more innovative and managing to reduce the operational use as well of the building, then the shift is towards the resource efficiency. And as many people said here, we need to be quite, you need to look at resource scarcity and see how we can reduce that as much as possible. So therefore, I think this topic about the last layer and move away from the conception that heavy building has to be heavy, like a 40 centimeter slab or something. And that is very interesting to see that we can combine and find out where the mass should be situated in a building as the external environment is less and less dominant because of all just the insulation and the way we can protect the building in the summer. So I think what's very important, what I take away is that there's not one answer, but something like we need to put the user, the building user, the human being at the center of the problem again, and see that how we can achieve this comfort, but also try to look at all the different components to reduce to get to this net zero, not just with having a very low consumption in a heavy building, but then having some more embodied energy, but try to make these really minimize the two together. And I think that's achievable with a degree of hybridity, of course, but also a nice control system. And it's very good news that we heard about, try breaking those myths about concrete or the concrete co-activation and things like that. So yeah, I think the future looks bright because we can actually, with innovation, we'll also manage to reduce further the environmental impact of concrete and cement, and how we produce these things with obviously less fossil fuel, and that how we can build also mass in a building using the ground, the storage. So all these things were really interesting. So I think I've been trying to listen every parties, and there's not really, I think you all concur in the end. It was not so much to the fact that, yeah, it needs this thermal heavy, but this light structure in a way, and that we just need to meet the needs of a building, either it's structurally in the basement, for instance, where you would need these materials, and depending where in a city where you want to build up another story, and then you need to use a lighter structure. And still bringing some mass in those places. So yeah, very interesting topics. Thank you.
Thank you, Anne. Thank you very much. And before giving the word to Susanna, who is from the more global architectural design approach, I come back to you, and I have the same question then that Susanna maybe also can insert in her takeaway. And my question would be, okay, we're talking about hybrid on building level, looking for good combinations to try to get the advantages of the components of the combination, to get them all as much as possible, as well as for the indoors, for the environment. Do you think that designers, engineering offices, consultants like you are, but you're also in research, so you have a small advantage there on knowing what you're beginning at. Do you think architects as well, do you think they are, one, willing to do that, able to do that? Because it is getting a little bit higher in challenge on what we have to deliver.
Well, I think it's, yeah, things are changing fast right now in our industry. I can see it in every architectural competition I'm doing. The objectives are so tough. I mean, in Switzerland, yeah, there's a lot of very strict objectives to be met in terms of the embodied energy and the operational use throughout the life cycle of the building. So I think architects definitely understand how to make volume works, how to make a flexibility in the structure so that it can be reused. So it doesn't really matter if you can justify having a bit more heavy material, a bit more heavy mass, if you can make it live longer and be durable as well, and reuse it after for another purpose. Repurposing is something very important as well. So depending on the span, the span of the slab or things like that. So yeah, flexibility in the structure and all this separating the different structure of the buildings, the three structures of the building. So I think architects definitely now are a lot more on top. It's still how to bring this without all the this diagram in that we use in MATLAB or things like that. But I think it's very important that we all discuss together with the different. I mean, in Switzerland, when we talk to the ventilation engineers and the heating engineers separately and things like that, and we all have this discussion on a daily basis. Yeah, it's it's coming, and also in Switzerland, the TAPS is no longer, I mean, the misconception, the things, it's moving again, and we can see some changes as well on understanding the control side of this. And of course, we know we use a lot the energy storage of the ground. So
it will increase the creativity in the design field. Thank you very much, Anne, for your takeaways and your considerations. Susanna, can I invite you to share us your takeaways?
Yes, thank you very much for the word. So I would like to say my resume of what I have heard today, it would be mostly that if we should decide, like from the environmental perspective, we should use the lightweight. And if we want to have a correct functioning of the building from the thermal perspective, so then we should use heavyweight. So then, of course, combining these two approaches, we come to a hybrid solution. I would like to add to that the hybrid solution not only help us in the thermal performance of the building, but we also consider acoustics, which is very complicated in the lightweight buildings, and the fire protection, which also is something that is much easier with the heavyweight structures. So that's something that I think is very important also to say for the hybrid. This is also related with your question, what you have asked, like whether we designers are able to design such buildings. So I would say not really in the terms of missing information, because the construction sector nowadays it provides products which are like very separated as systems. So there is a provider that gives us the wooden part. There is another provider who gives us the concrete part, but there is not really a system that could have a defined performance that would be certified, that would be tested, and that will tell us, okay, this system behaves like this, like this, like this, and then we can apply directly in our buildings. Because without the certifications and without the performance, we cannot really do such systems. And making testing, for example, particularly for one project, it's not feasible unless we are Zaha Hadid or someone like that, no? So I think this is one part, and another takeaway or another maybe question or maybe a topic that I think it would be interesting to discuss is the circular economy. So considering let's say the systems, the taps, for example, or radiative systems for heating, how should we design these in order to reuse them later, for example, or recycle the materials, because they are now connecting several different materials and makes it very complicated then to treat them at the end of life of the buildings. So for example, I know there exist like floor heatings that already use like dry screed, that it's like just a plate put above, but then is the performance the same? Can we count on the same performance? So I think this is a question that I would like to put to the rest of the people that we are here present, and it would be something that, well, I personally am interested in. Many thanks.
Okay, thanks a lot, Susanna. I think we all agree that we have to go hybrid, that there is a huge advantage in combining both light and heavyweight structures. And thanks, Susanna, for pointing out some challenges we still have. So we are not yet there. So maybe this is a good idea to set up together to look into this deeper. We have about 13 minutes left for some Q&A questions that have been posted in the chat. So Lukas, can you give me the first one that we need to answer?
Mm-hmm. Yes, we have some questions here. We have two offline questions, so I will read them first. The first one is probably for Stefan, and I think he also wants to shortly react to Susanna. So is there some typical mix of timber and concrete? Can you tell what is the typical ratio if you use, you said that I think this question relates to the pictures that you show, that there are concrete cores and timber structure around. What is like the typical ratio of the use of timber and concrete in the buildings?
Well, in most of the cases, I guess, related to mass, 50-50. Related to volume, it's a bit more timber compared to the concrete. Finally, it depends on the building situation, of course. There is no fixed rate or something like that. What you have to understand is that we have hybrid buildings on the building level, so concrete core and a timber structure aside, for example. But of course, we also have hybrid construction products like a timber concrete floor as a composite structure. So you have both levels, of course, on the floor or wall level, so on the construction products level and on the building level. Let me answer an additional question from the FNQs. There was one question who asked, is it meaningful to cut trees which are uptaking carbon dioxide and to use that in a building? There is a very short answer to that. Yes, it makes a lot of sense. Why? We are harvesting old trees, and old trees have a limited life span like we have as human beings. So if you would not cut it, it would fall down after 80 or 90 or 100 or 120 years and will rot in the forest. And this will then give carbon dioxide emissions again to the atmosphere. So that makes a lot of sense to cut old trees and to use it in a structure, because as long as we use it as a material, it provides a carbon storage and thereby a CO2 sink. And the new trees we are planting at the same time in the forest, and this is of course only valid in our areas where we have a sustainable forestry, the new trees we are planting in our forests, because they are younger and growing faster, they take up more carbon dioxide from the atmosphere. And there are a lot of scientific-based data about that it is much more better to use timber in buildings based on sustainable forestry, of course, than to leave everything in the forest. Second, fire safety. I think I'm researching now since more than 30 years in the area of fire safety. I can provide you a lot of fire safe constructions up even for high-rise buildings. I have shown the Brumunddal building with a real high-rise with 18 stories, 120-minute fire resistance, everything solved in it. Even in Germany, where we are quite conservative with fire safety regulations, we are able to build up now to high-rise levels, so 8 stories on regulated basis. There may be some countries in Europe which are a little bit behind, but in most of our countries, we are now allowed to build up to the high-rise building level, also with fire safe regulations and without any need of exceptions. So that's solved. And you also know testing, Susanna. to build that. A lot of it is standardized in between. We are doing actual revision of all the Eurocode standards, where we implemented mass timber, for example. We implemented timber concrete composites as a new technical specification, which will come to the market very soon. There are a high number of European technical approvals for those building parts like floors, walls, etc., etc. You don't need research, you just have to apply it. It's, the problem is probably that the spread of information is not sufficient enough, but if you want to have a look, for example, in timber structures, use the website dataholz.eu. It's public, and you will find a lot of constructions there which are completely certified. So you have all what you need for your regulators is in this database. So it's completely verified. And your last question, reuse, that's a very big question for every one of us. And especially if we start to think about to reuse the real floor element, the real wall element, not to destroy it, not to downcycle it, not to shredder it and then to make another product out of it, which is on a lower level. The very interesting question for the future is, of course, are we able to find constructions which are really reusable, so that we have to think about disassembling, of course. We have to think about connections which we can end-tighten again, etc., etc. So this is a research. This is valid for nearly every construction product, from concrete to masonry, to timber, to steel, to glass, to membranes, everywhere. Now that's a big question for the young people in future. Welcome to any research team dealing with that.
Thank you for the answer, Stefan. Next question. I have heard about model predictive control to be used in activated structures. What is it trying to accomplish, and does it work? It's maybe a question for Lieve even. Does it work, Lieve?
I'm not here to answer the questions. I'm here to pose the questions. So.
I will be glad to answer.
Yes, please, Gerne.
I think the MPC control, and I feel that's one of the outcome of the project we are just finishing, is in buildings, for example, with taps, may not be that important to control the indoor environment, but it's very important to control the energy use, when to use the energy. And if you both have heat pump and you have ground source systems and so on, there is a potential for more efficient energy use if you use a MPC control. So it's mainly for the energy use, maybe not so much for controlling the comfort.
And maybe if I may add there that using energy in the current society, where we have to move towards renewable energy sources, and we have the connection with the energy system, that becomes a challenge as such. And I think indeed, Bjarne, I agree that MPC can make a difference there. Okay, Lukáš, over to you again.
Can I add something on MPC? Sorry, I put something in there because I just heard the name. We made a lot of studies with MPC and compared them to standard control systems, also by activating concrete stuff with solar use and whatever. So predicting the weather next day and putting more heat into the concrete and all things like that. So our findings was also with other control systems that MPC gives you maybe an advantage 5 to 10%, not more, compared to standard, let's say more or less intelligent control systems. My suggestion is here, keep it simple and stupid. Make it as simple as possible, your control system. The more sensors, the more actuators, the more computing you have, the more possibilities of failure you have. Of course, you sell less money. So every control guy will sell you a lot of bunch which you don't need, but try to get spare parts after 15, 20 years for that stuff. So you have to replace it every 10 years, but you don't know about the costs. And as you have a lot of degrees of freedom in here, you have a lot of possibilities of failure, and you have many sensors that can fail, and you have actuators that will break down and the motors will not work. So I think here it is, let's say, you sell some artificial benefit, which in practice you will never see. So I have a speech going around, it means only stupid buildings need artificial intelligence.
I like the slogan, but you don't have a car, do you?
I have a car, sure, I have a car. I have also a computer, I know that, but I have a building that I want to have for 50 or 60, 70 years. And I don't want to have a computer for that time. And if you try to get spare parts for your cell phone after 5 years, you will fail. And if your car is telling you that something is not working and I cannot go anymore because there's a sensor broken, we all know that problem. I don't want to have this in a building.
I understand. And that's one of the values, of course.
The most reliable car is my old Land Rover.
Okay. So the basis of the concept should not rely on the sensors. So it should be robust. But to fine-tune it a little, imagine that we don't have a security of supply of energy or heat or cold, and that we have to try to shift things towards moments that it is available. Then it could become a necessity to have some controllability there.
No, if I have thermal mass, then I put the heat in when I have the sunshine and I overheat a bit. And then if I don't have no sunshine, I live from the thermal mass. You can do it very simple. Just think a bit. Yeah, as simple as possible. But of course, you have to understand the whole building and as a system to do that. And you find nobody supporting you because everybody wants to sell stuff that nobody needs because they have a bigger market with that. And the final customer has to pay for all that, the maintenance, the investment, or the operating cost. They have no clue. One example, we have in our buildings, we have a Siemens control system. If we want to put the shadings in this nice building, which I told you, we want to put since 3 or 4 years to make the shading in the east side go down in the morning and the south side during noon, and then the west side in the afternoon when there is sunshine. We have some PV sensors on top, but we have no access to the Siemens control mechanism inside, so we cannot program because we did not buy for that and they will never sell it. So for every change we want to do, we have to make a contract with Siemens, and we have no chance to see what they are really programming, and then we have to look if they did it right. That is the reality where we face. So we open degrees of freedom which we will never be able to use.
Okay, Wolfgang, but that's more a pledge towards a monopolization of a black box. And not a pledge towards not having controllability that could help us in having the clean energy used instead of, because you said you have to be intelligent.
Yes, the building must be intelligent with the thermal mass, with the orientation of the windows, with the shading system, maybe operated manually, a shading system that allows opening the window at night, all that stuff. And placement of thermal mass and so on, orientation of the building. That is intelligence in the building.
That's
it is not, it is, yes, that's the design intelligence, including this self-control system of heating and cooling where you need as little as possible sensors. So it must be the goal to have as little as possible electronic sensors, actuators in the house, and it should still work.
Yeah, but I think we do have some variability in real operation that not all can be incorporated.
No, it's not all, but don't make an overkill. It will never work.
Okay. We just had a discussion this afternoon. If somebody uses a concept and he knows 4 days in a year, it will not work really. So maybe the people will stay home to work. Okay, now this is not an issue, but then probably they will not choose for the concept.
Yes.
Okay.
And if I might,
yeah, I think we have time for conclusion of today's roundtable. So Wim or Lieve?
Okay, I will try to conclude and Lieve will correct. So those are two tasks. my first conclusion is it's getting very interesting for designers and challenging for designers, because there's no things on the shelf. We know that there are not solutions as such that you can choose, but you have to create your solution according to the building. And the building sector changes a lot. The way we make buildings, the architects make buildings, how we want to work in buildings, how we want to make them work, that changes. And in this transition of living, of working, we have to integrate the transition of energy use, using as much clean as possible and being very respectful towards our natural environment, and of course creating an indoor environment that has a comfort level that creates well-being, productivity. So it means that our task in practice is getting much more challenging. So we do need some intelligence, Wolfgang. We would welcome more artificial intelligence in that, because I don't think in any of the European countries we have an increase of engineers and masters coming out of universities. That will not go that fast, and certainly not for the construction industry. So I do think we need tools. We need ways of having a building and it's controlling mostly by itself, but still being sure that the one who designed it knows it's going to work and it can be reliable. And also the control will be a part of that, even if it's mainly the control of the shading. Okay, if we can do it just with the shading, that's good. I think my main conclusion is that one of my questions, and we have a lot of questions left for further editions. One of them was effectively the resources, the chain of concrete, the chain of wood. Can it be better? Because both are criticized sometimes. So we should define what is the good way in the construction industry to be environmentally responsible. And it accounts, of course, for concrete and steel, but also would have some sideways that we should clarify more or make them more known in practitioners' environments. Lieve is not going to correct me yet. So I just would like to thank, of course, the people of the UCEEB for the cooperation together with Enercore, which is going to launch its activities looking at storage in buildings, technical supply technologies that use clean energies, no fossil energies. So that's the Enercore objective, and thereby using innovation that enables, that facilitates it, not only for the construction industry, also for the designers, also for control engineers. So I think that's what we're mainly, coming from the Hybrid Geotubs project, are trying to put serious steps forward. And of course, we invite from the Enercore launch, we invite everybody from practice and research to promote and to go further in the challenge, even if it's research challenge, to sit together with the people who have good starting points for that. So I think that's about my main issue. I would like to thank all speakers. I know them very well. I know them even better now, and some I didn't know, but now I have a good impression on a broad view on what we are doing and trying to do every day. Lukas, thank you very much for initiating.
Thank you.
Lieve, very much for moderating, and all the ones that put the questions down. You will probably have a mail trying to make more visible what both in the Czech Republic as in Brussels we're going forward with. Thank you all and have a great afternoon.
Thank you very much.
Thank you. Bye-bye.
Thank you.
Bye.